Hi guys, how are you guys? Hope you're well. In this video, we are going to work with question 2. Yes, it's a continuity of our previous video, which is Gauteng Preparatory Examination Mathematics Grade 12 Paper 1. If you are new to this channel, what are you waiting for? Kindly subscribe. You only subscribe once. Thank you in advance. Without wasting time, let's get to today's video. Right, guys, in this video, we are going to work with patterns. So the first pattern says that the following is an arithmetic sequence. We're given 1 minus p and 2p minus 3 and p plus 5. Calculate the value of p. How many marks is that? That's 2. Right, let's start with the value of p, guys. Right, we can see that we're given in terms of variables. So we have to work out the variable p here. Right, what you should denote is that when you're working with variables, remember that it's t2 here minus t1, t3 minus t2. That's the technique that we are going to use here to find the value of p. So without wasting time, let's do it. Mind you, we are given 1 minus p as well as 2p minus 3 as well as p plus 5. So what are we going to do in this case? We're going to say that, remember, this is t1 and this is t2 and this is t3. So first thing first, we're going to say 2p minus 3 subtracted by 1 minus p, which is equal to p5, which is t3 minus t2, subtracted by 2p minus 3. So let's work out the left hand side first. When we take out the brackets here, we are left with 2p minus 3. And remember that the negative affects everything that is inside the bracket. So we are going to have negative 1 plus p, as well as we are having what here? P plus 5, and we have negative. That negative will multiply negative 2p, negative and negative, that will be positive. So we've already worked out the left hand side and the right hand side, right? Now the like terms. So what is 2p plus p? That will be 3p. So what is negative 3 minus 1? Remember that those are integers. That will be negative 4. So in this case, we have p minus 2p, which is negative p, 5 plus 3, which is 8. So we're going to say 8 minus p. Collect your like terms. So from there, you can take negative p to the other side. It changes. It will be positive. So we're going to have 3p plus p, which will be 4p. So let's transpose negative 4 to the other side. That will be 8 plus 4, which is 10, 12. So we are going to have 12. Then divide by 4. How many times does 4 goes into 12? That will be 3 times. So in other words, p, it's 3. So that's how you can get that 2 marks. They're stingy, no? They're stingy. 2 marks for just working out p. Right, write down the value of 2.2.1.2. Write down the value of the first term of the sequence and the common difference. All right. As well, those are 1 marks. 1 mark, 1 mark, 1 mark, 1 mark. Right. So this is 2.1.2. Then we have A. They said write down the value of P. Write down the value of the first term. So to find the first term, we need to take this 3 and substitute to this first term here. So we are going to have, we're going to say 1 minus 3, which will be negative 2. So the first term will be equal to negative 2. Okay, so let's go to B, the common difference. So let's substitute 3 in every term there. So we are going to have negative 2. So let's put 3. 2 times 3, that will be okay. We are going to say 2 multiplied by 3, that will be 6 minus 3 that will be 3. So we are going to have 3 here. So as well as we are going to say 3 plus 5, that will be 8. So let's see the difference here, which is the common difference. 3 minus negative 2, 3 minus negative 2, that will be 5. So as well as 8 minus 5, 8 minus 3, that will be 5. So the common difference is 5 in this case. So common difference will be 5, equal to 5. Are we fine, guys? Then they say at 2.1.3, explain why none of the numbers in this arithmetic sequence are perfect squares. Explain why none of these numbers in this arithmetic sequence are perfect square. Why none of these are not perfect square? Why none of the numbers in the sequence are perfect squares? We can only explain that by finding the difference. The general term. So remember that we have our parts in there. So let's call this a difference. I'll name it B. The first term, I'll name it B plus C. Or you can use this one, Tn is equals to An minus 1D. Right, so in this case, I prefer to use B as our common difference and B plus C as our first term. So that will be equal to negative 2. And we have B as 5. So it's going to be 5 plus C is equals to negative 2. Then substitute 5 to the other side. It will be negative 2 minus 5. That will be negative 7. So writing it in a linear form, it will be Bn plus C, in which your B was 5n minus 7. So they said explain why none of the numbers in this arithmetic are perfect square. Why none of these are a perfect square? Right. So according to our formula, it's Tn, which is equals to 5n minus 7, which is the general term of this sequencing. So guys, we know that the perfect squares, we talk about 1 squared, 2 squared, 3 squared, and blah blah blah. So which will be 1, 4, 9. But here, if we can substitute, for instance, let's substitute 5 times 5. 5 times 5, that will be 25. 25, it's a perfect square. But when it's decreased by 7, it's no longer a perfect square. So whenever because it has been decreased by negative 7, it can never be a perfect square. So that's how you can explain your explanation at 2.1.3. So that's how you can explain it, right? So let's go to 2.2. The following sequence of the numbers form a quadratic sequence. Okay, the following sequence of the numbers form a quadratic sequence, and we are given negative 3, negative 2, negative 3, negative 6, negative 11. Then at 2.2.1, the first difference of the above sequence also form a sequence. Determine an expression for the general term of the first difference. How many marks is that? That's we need to find the expression or the general term of the first difference. So let's put this into practice. Okay. So we have what? We have 2.2 and 2.2.1. Remember that this is negative 3, negative 2, negative 3, negative 6, negative 11. Then let's make it fashionable. So we have what? Negative 2 minus negative 3. What is that? That's 1. And what is negative 3 minus negative 2? That's negative 1. What is the difference between negative 6 and negative 3? That's minus 3. Okay. So what is the difference between negative 11 and negative 6? Negative 11 and negative 6, that will be negative 5. So as well, So what is the difference between negative 1 and 1? That's negative 2. What is the difference between negative 3 minus negative 1? That's negative 2. What is the difference between negative 5 and negative 3? That's negative 2. So you may recall that this is your first term according to the quadratic sequence, and this is your first difference, and this is your second difference. So in this case, they are looking for the general term of the first difference. So the first difference is this one, guys. So which has a common difference, right? So I will just say let this this is our difference. I will say let our difference be b, which will be negative 2. We want to find the general term, right? And the first term will be 1 in this case. So the first term will be 1. So I'll just say b plus c is equals to 1. Then remember that our b is negative 2. So it's negative 2 plus c, which is equals to 1. Then we can transpose negative 2 to the other side. So that will be 1 plus 2, which will be 3. So in this case, the general term will be bn plus c, where your b it's negative 2 and your c it's 3. So that's the general term, or the general that's the general term for the first difference. Or you could use this method, Tn is equals to an plus n minus 1d. You're still on the right track, right? Okay, we can check to verify where there's n. Put position 1 plus 3, we get positive 1. Let's put 2, we get negative 1. Let's put 3, we get what? Negative 3. Let's put 4, we get what? Negative 5. So it's correct, right? So let's that's the solution in 2.2.1. Then let's go to 2.2.2. At 2.2.2, calculate the first difference between the 35 term and the 36 term of the quadratic sequencing. Well, in this case, we need to find the difference between the 35th term and the 36th term. So finding the difference of that, it's the same as having, let's say, what is the difference between negative 2 and 3? That's 1. The difference between negative 3 and 2, that's negative 1. The difference between negative 6 and negative 3, that will, between negative 6 and negative 3, that's negative 3. So in this case, we are going to use our general term. So we're going to say T35 is equals to negative 2 times 35 plus 3. What is that? So the difference, negative 2 times 35. Oh, what will be that? Plus 3. That will be negative 67. So the difference between T35 and T36 with the quadratic sequence will be negative 67. That's how you can answer that question. Mind you guys, those questions are, the first one had 3 marks and the other one had 1 mark, right? Okay, let's go to 2.2.3. Determine an expression for the n term of the quadratic sequence. That is 4 marks. We need to work out 4 marks in this case. That's 4 marks, guys, right? Okay. Let's get, without wasting time, let's work it out. Let's go back here. Remember that this is 2a, and our first difference, this is 3a plus b, and this is a plus b plus c. So let's put that, remember we're working at 2.2.3. We are going to say 2a, which is our second difference, which will be negative 2. When you divide everything by, when you divide both sides by 2, you get negative 1. So we have 3 times negative 1. Remember, we're following the first difference there, plus b, which will be equal to 1. So in this case, 3 times negative 1, that will be negative 3 plus b, which is equals to 1. Take negative 3 to the other side. The same as 1 plus 3, which will give you 4. Then we have a plus B plus C, right? A plus B plus C, what is that, guys? Remember, A plus B plus C, it's a first term, so that will be -3. So we have our A is -1, our B is 4, plus C, which is equals to -3. So what is -4 plus 1? That's 3, plus C, which is equals to -3. Transpose 3 to the other side, it's the same as -3 minus 3, which will give you -6. So writing our general term of a quadratic will be an squared plus bn plus c. Let's substitute. A will be negative, so we're going to have negative x squared plus 4n squared here, plus 4n minus 6. Right, that's the general term. So that's how you can get that beautiful 4 marks, guys. So let's see the last question. Show that the sequence of the sequence of numbers will never contain a positive term. Remember that you were given we have already calculated the 2.2.3, that our general term is negative n squared plus 4n, plus 4n minus 6. So how will we determine that our sequence will never contain a positive term? We will determine that by finding the turning point. If you can find the turning point, in this case, let's say it's going to be negative b all over 2a. Remember, it's a quadratic formula. So if we can, remember that our b there, it's -4 times 2 times -1. So we know that will be -4. And 2 times -1, that will be -2. How many times does 2 goes into 4? It goes twice. That's the first point. So, but what will determine whether this contains a positive term? It's our y value of a turning point. So you are going to take this x value and substitute here in this formula. If it's positive, then it will contain positive. If it's negative, then if it's negative, then it will never contain a positive term. So what are we going to do? Let's substitute them. Where there is n, you put 2 plus 4 times 2 minus 6. So we could see that we get negative, if you substitute positive 2, you get -2. So we are going to have 2 and -2. So that tells you that your turning point will be at minimum. It will be at minimum. So will our sequence contain a positive term? Nah, it won't be. It won't be. So that's how it should be. That's how you can work out question 2. That's how you can feel free to comment on the comment section, right? See you on our next video, which is where we are going to work with question 3, right? And hope you find this video useful, and do not forget to subscribe, and remember, we love you.